name is Samar Hasuna, and I'm going to be talking about the transformations of a polynomial function. So a vertical shift is defined as a graph of y equals fx plus c shifted up c units if c is a positive integer. So if I take the function f of x equals x plus 3, our power function is x, and then our c is 3. So if I looked over here, x, my power function, is a slope of 1, and it sits along the x and y axis where they intercept. But if I take the plus 3, which is my c, all I really have to do is shift it up 1, 2, 3 points and then graph the exact same line. And that gives me my final graph. On the other hand, if c is a negative integer, then we have to do the opposite. So if c equals negative 3 in the case of x minus 3, then it's almost the exact same thing as my original graph, except now I'm going to shift down 3 units. So if I come over here, this is my original function of x. I'm going to shift down 1, 2, 3 units, draw the same slope, and that is my new graph. But also, take note that these are not in parentheses. If the function is in parentheses like this, then it becomes a horizontal shift. If the f of x is x minus 2 in parentheses, then we shift either left or right based on if it's positive or negative, and it's the opposite of what you would normally think. So x minus 2, instead of shifting to the left 2 like we would normally do if it was vertical, we shift to the right 2. So my power function is still x, except I'm pushing over 2 units to the right. So I'm going to go 1, 2, same exact slope, and the same goes if it were a positive integer. If it's a positive integer, now we're going backwards to the left 2 units. So it's 1, 2, same slope. And if you want to plot a point that proves this, I can choose any point. So if I were to choose 1, if I looked at my 1 for my x equals 1, y equals 1. But if I took x minus 2, 1 minus 2, then I would have, x, let's just skip that part. If I took 1 plus 2, then I would have 3. So if I plot 1, I would go up 1, 2, 3, and that would be my next point. And that is my final graph. In the cases of horizontal scaling, all the c's must be positive or else it won't work. For the example of y equals f of c times x, if c is greater than 1, then the graph of y is the graph of f of x compressed in the x direction by a factor of c. So if we have y equals 2x squared, our power function is x squared, which is the black right here. X squared is a parabola in normal cases. And so what happens is if we take 2 and multiply it by the x squared, then the whole graph will be pushed inwards like so. So our new graph will look like a smaller or sharper version of it. On the other hand, if c is greater than 0, because it has to be positive, and less than 1, then the graph is stretched in the direction of x by a factor of c. So if we have if y equals 1/2 x squared, our power function is still x squared and still has the parabola, except this time the points are going to be further out. They're going to be stretched out like so. Okay. So vertical scaling is almost the same thing as horizontal scaling, but it's not at all. So for both cases, c has to be positive, but in this case, for vertical scaling, what you're doing is you're multiplying your c times x squared. So what you do is you square x first, and then you multiply it by 2. For horizontal scaling, you multiply the 2 times the x, then you square the whole thing. So if I were to take the function x squared, as it is here, and multiply 2 times x squared, then it would be stretched in the y direction, which would mean that it's going to pull along these lines. It's going to become bigger that way. So the end product will look like this. The same goes for if it's between 0 and 1, because it has to be positive, except now it's going to be compressed in the y direction, like so. So it's going to be wider and closer to the x-axis, like so. For reflection about the x-axis, the graph of y equals negative f of x is the graph of y equals f of x reflected about the x-axis. So basically what that means is you're taking a negative sign and you're multiplying it by every solution you get for your original function. So the original or power function that I have for my function here is x squared. So what I do is I square x first and then I multiply it by a negative. So almost every positive y is going to end up as negative, and then every negative y is going to end up as a positive. For this case of x squared, all my y's are originally positive, so that means my finished product is going to have all negative y's. On the other hand, reflection about the y-axis, the graph of y equals the f of negative x. So it's similar, but you're multiplying it by negative first, and before you cube it or square it. So for y equals negative x cubed, I multiply my x times the negative number first, and then I cube it. So for all my negative integers here, it would be positive first, and then I cube them. So it's going to look similar to this. And it's flipped about the y-axis.